Oh, okay. Okay, so we're going to talk about the different objects that are going to be required in this next assignment if you've got the PDF in front of you. And so with these, you actually just need two views for each of these four objects that we're going to be looking at here. One of them I discussed this morning, so that's the feed block on page 173. And we'll look at some of the other objects here and what has to be done with them. Okay, so this is one that I looked at earlier with you guys, our little sketch here about what that's going to be like with the countersink and the counterbore. So that's one where we're going to be providing a top view, so seen from above, so you can see this slot goes all the way down. And that's it. Now, some of these faces, you're going to see this funny little flag symbol. Now, you won't have to redraw this flag symbol, but what that means is it's a finished face, like it's a polished face. Uh, it's been machined, so it's super smooth. So that's so these things can sit right up against a very polished or a very well machined face, and it mates up against it without any imperfections. So the feed block is pretty straightforward. Let's go on and look at the single pulley. Okay, so this is the one that everybody gets wrong. And remember what I said earlier about that if the students don't get it right, it's the instructor's fault. I always tell my kids, if anything goes wrong with you in life, just remember, blame your parents. It's their fault. Okay. So this goes right back to the question we had right at the beginning of this thing. Why don't we show? So we're going to be doing a section of this thing. Why do we not show the spoke sectioned? And that again is just so we don't give the erroneous impression from the section that the spoke is continuous all the way around. Here we've got actual, significant gaps in between the spokes. So this part is going to be not shown sectioned. Now, they've got a little detail view on the end here about how this rim is to be drawn. You don't need to draw the rim detail. This is just to help you draw it when you do the section through the pulley. And we're not going to be doing this cutaway either. You're just going to do a straight section right through the middle of it. So what that's going to look like is we're going to have the rim, and then you're going to transition to the spoke. And then you've got your hub. And the hub has a keyway in it, so keep in mind that you're going to have to draw that slot for the keyway. And then we go to the other side of the hole. And back to the other side. Spoke on the other side. Yes. Yeah, I had the Word document obscuring my live stream, so I couldn't see that I had gone off screen here. So, anyways, yeah, the point being, so you've got your keyway here, so you've got your opening, And so your section through this thing is going to show the rim and the hub sectioned, but not the spokes. So in here, whatever the size of your keyway is, it's going to make the material a little bit thinner on one side of the hub compared to the other, of course. So end up with something like this. And there's your center line that goes right through that thing. Showing them but not sectioned. So so again, the reason that it's not being sectioned through, even though our section line is following exactly what you see here in the cutaway view, but this is again, it goes to the convention of showing, the fact that this spoke is not continuous. Like this isn't a solid thin flange all the way around. There are holes in it, and in fact, the majority of the center part of the wheel here is air. It's not material. So hence this representation of it. And yeah, go ahead. Uh, Anytime if there's a gap of material inside, that's kind of the trigger right there. So unless this was a solid flange all the way around, you'd still use this convention. So, if you had a different situation here, and I'll just draw a very simple top view. So there's a hub and then a rim around the outside. So even if we had small little holes like this, like just almost little gaps, right? So even then, we'd still use that same convention where we would show it discontinuous because we want to really tell someone, hey, you know what? There are some holes around this thing radially that, this isn't solid material all the way around. So in a sense, your drawing is, your section anyway, is it's a lie. Like it's not really showing, right? So, but that is on purpose. It's like you went up to your parents and you said, I want a motorbike. And your parent turns around and says, you'll die if you get one. No, it's a lie. Well, maybe it isn't. But that's because I'm a parent, right? So it's like, I got a kid who wants a motorbike really bad. He's like, I want to start out with a 600cc bike. And I'm like, you're going to die, dude. You are going to die. Um, so we do this because we're trying to, get to the uh, clarity on this thing, which is that this piece of material between the rim and the hub, the spoke or the web that's in between, it is not solid material all the way around. So anytime there's a bit of a gap, and it's a bit of a call, but most people who are sectioning through this, even through a wheel like this, where like you can see 80% of the spoke area, if you will, is solid. So these are like, I mean, look at that. It's only like 10%, 20% of the spoke area is air, but nonetheless, we'd still use the same presentation. And what it is, it's designed to say this is a sort of a weaker or kind of a background thing. It's discontinuous, but this is continuous. Like this thing here. Okay, so what happens is, and I didn't maybe draw this quite correctly, is if you were looking at there is a bit of a round here, so, or a fillet, I should say. So it actually does this, and you would not see those bits of lines coming right down to the end. So when you guys draw this, you can see here what you'd see. So let me just draw that again. So the spoke comes down, and when it hits the hub, it's going to round out, it's going to flare, and that's what you're going to see. And then sectioned material below that. So that's this location here, which I'm drawing right there. That's right. Solid material and not solid, right? Like so this, yeah. So that's the idea. So that when someone's viewing this drawing, like, okay, so from the edge of the hub to the edge of the rim, like that's where the rim ends, and that's continuous all the way around. And this is the edge of the hub, which is continuous for 360 degrees. But in this zone here between the hub and the rim, this is not continuous material, it's discontinuous material. So here you have a discontinuity between this spoke and the next one because, there's some uh, gaps in the material. Now, some other stuff to talk about here. This is not something that's if it's in a textbook, I didn't stop to uh, talk about it, and it's a tolerance. Now, this is something you'd still put um, into your notes. Now, here we've got a hole that's going through the hub, and this hole can be anywhere from 34.02 millimeters to 34.08 millimeters. Now, what are you going to draw? Well, just draw 34 because there's no way in heck that anybody can see, anything, the difference between 3402 and 3408 anyway. So in real life, yeah, it's a tolerance. So when these people are drilling this hole through, you want to make sure that the 34 millimeter shaft can slide through this thing without getting jammed. So the hole's got to be at least 3402 so you can get the tube through it, so you can get the shaft through it. But if it's any larger than 3408, it's going to be wobbly, right? It's going to rattle inside it because the hole's too big. So this tolerance, when you see two numbers like this, it just means, make it anywhere from that size to that size. And somebody's got the machining to deal with that. So that's a tolerance. So just draw it at 34 and then just put these in your notes with the liter and with a little diameter symbol on it. Stack the numbers like you see here. Now, what we have on this thing is we have some rounds and we have some, so here we've got some fillets, R3 fillet right here between the spoke and the hub. But then we have what's called a chamfer. So here on the edge of the hub, and I'll just draw this here at a larger scale. So a chamfer is where they grind off it's a flat grind. They grind off a face on the hub. So sectioned here, this is what it's going to be. That's our material. And so when it says 1.5 at 40 degrees, it means the distance from the face of the object back to where the chamfer ends. So what we're saying is that distance right there is 1.5 millimeters. And it's 1.5 millimeters in both directions because it's a 45-degree angle. So that is known as a chamfer. You won't have to note it as a chamfer. Everybody in industry knows what it is, so no worries there. Now here, where we have our spoke meeting the hub, so this thing right here has a radius of 3. This is a peril of being left-handed. You're always dragging your hand over your work and smudging it all the time. Yeah, it's a bit of a drag. So all you righties out there, thank the gods above that you are right-handed because can get to be a bit of a mess. Okay, so that's that one. So just remember again that the spokes aren't continuous, and then you will largely be on your way. Okay. Now the next ones are actually fairly straightforward. They're um, sections now. So we'll talk about these, and we kind of hinted at some of the techniques or methodologies that we're supposed to use. You can see when someone here has already been sketching up the the jog in a section. There's some other sketching going on here. Okay, so it's the fixture frame. If there's a difference between a scale on the assignment and a scale in the textbook, use the scale in the assignment, because sometimes the scale in the assignment is different because we know it's not going to fit on a sheet as easily. Okay, so with this one here, we'll just talk about the strategy for this. So it's just a top view and a section view, but there's some trickiness to this. It's tricksy if you're a Gollum fan. Tricksy little hobbitses. Okay, so when we draw this fixture frame from above, you've got the radius here, and we've got some shoulders, but you will have to engineer what the full width of this is by doing the math. So we've got 44 mils between the center of these two holes, and then we've got a radius 13, and you can see the arrow here. Let me just get that up close to the camera so we can talk about it. The R13 down here in the corner. You can see how that arrow. Shoot! I just dropped my tracing paper and it unrolled all over the deck. Womp womp. So there, R13, it's pointing to the very ultimate outside of the object. So that means we've got 13 mils added on both sides. So it's 26, right? 2 times 13, 26 plus 44. So I think that's 70. 70 wide for that piece right there. Okay, I'm just going to get that trace paper and roll it all up again here as I'm talking to you guys. So yeah, it makes sense to do the top view first, and then we'll come back and do the section view. So here I just got to use that drafting table to roll this stuff back up again. So just trying to think if there's anything tricky about the top view. It's actually not the top view that's too difficult about this one. It's entirely the section. Oh yes, yeah. This is going to be a jogged section, so it's not. You know what? It's. Oh no, guys! This isn't accounting. This is fun. Um, okay, so let's just do a quick top view sketch here, so we can kind of talk about the shape of this thing and what will, how we will section this. I have got this completely wrong. So there's a second hole at the top, and then a hole in the middle, holes around the sides. We've got the slot. Yeah, this is getting a bit of a cluster cuss here. So, okay. So the section line is going to jog a bunch, but in the end, this actually isn't going to be that serious a drafting exercise when we cut through it in section. I'm just looking for my colored pen here so I can talk about the section line. I'll do it in red so it's easier to see. So what's the section on this one going to do? What's the best way to go through the right end of this thing? Well, we'll just start in the middle. And we'll go right through the middle of this hole. So that's step one, and that's pretty straightforward. Now, we want to catch one of these slots. So it doesn't matter whether you go forwards or backwards. You just make sure that you're looking in the same direction all the time. So I'm going to come back and I'm going to go through this slot. Now when I get on the other side, I'm going to jog back over, go through the center of the hole, come back out, and go through the center of that hole. And that's the way we're going to draw the section. Now that looks torturous, but it's actually not that big a deal. Now, for drawing the actual section line that's going to be on this thing, what would you do? Well, to be honest, I wouldn't draw this crazy section line. I wouldn't even bother with that. At the very least, you would do something like this, where you'd show that you're going through the section or the middle of the object here. And then at the other end, when you come out on the other side, that would be really considered sufficient. You wouldn't have to put any of that red business or anything else in the section line in there. When the fabricator looks at your section and sees a hole here, a hole here, and a hole here, they're going to be like, yeah, okay, I see what you did there. And that'll be totally good enough. So let's look at the section. So here you can see this jogs downwards just at the very end here. And then this thing where the circle, inner circle raises up, it's proud of this plate above and below. Okay, so then we've got the little piece of the circle above and below. So with, yeah. Now I'll have another nice, lovely picture of this thing for you guys, which I'll stick in the ADT1 channel, so that you'll be able to see all that. So you can kind of see how this thing is built here, and so there's my resulting section that's going to be through it. So now we got to talk about, what am I going to show sectioned? What's happening here? Now, this has almost kind of been drawn as a bit of a front view, so there's a couple of minor errors in it. So first of all, here we're going to transfer our slot up, and that's going to be drawn right through. So in this one, we've got our big hole in the middle, and then the two holes in the sides. So that hole goes all the way through. And I think these ones here, they're only 16 deep, so they don't go through. This one says diameter 17.5, and this center hole goes all the way through, but these four smaller ones do not. So you're going to see something, I don't know if I've got this quite right. Right? So these holes don't go through. Now this line that you see, I accidentally drew that as going through. It's not. So I'll fix that when I start doing my section line. And because I did it in ink, I can't erase this little piece of line right here under my pen, because that shouldn't be there. Okay, coming back down, we've got our big spot face here. Not a spot face, probably a counterbore, 7 deep. And then we've got a hole that's 19.5. So that hole here goes all the way through and then steps back on each side. There's going to be something like that. And of course, you see the object line going across. Then we're cutting through for a hole here. So it's got a counterbore 15 deep. And then diameter 11, 10 deep, 2 holes. Counterbore 15. Oh, I see. The counterbore is 15 deep, and there's 2 holes with a diameter of 11. Okay, all right. So the hole goes all the way down, and then there is a 15. Okay, so it does. A 15 counterbore is 10 deep, and the 2 holes are 11 diameter. So sometimes the wording up here, and you're like, what? But the counterbore has a depth, and the diameter is for the hole. So you got two holes that are 11 deep. So I think sometimes they on purpose put the information here in some sort of backwards order so that you have to think about what's going on there. So there's our hole, and 15 wide. So something like that. The object line for the counterbore, don't forget that. You'll need that as well. So we're kind of sorted here. So now I can start sectioning this. Now, the next part of this that's going to be tricky is talking about the center lines. So these slots have they're half circles at the ends. So the slots end in a drilled hole. So typically when they're machining something like this, they'll drill the holes first, and then they'll have a router bit that will just zip out all the material between those two holes, and that's how they create that slot. So when we're showing the slot in plan, it's going to have a series of center lines that get created. And I'm going to draw this a little bit larger because that's kind of small and a bit messy. So there's my slot. This isn't really much better. Okay, so I'm just blowing on it to dry it off as quickly as I can. We've got our center line for the holes that were at each end. So we want to see a center line there vertically. This is a circular shape all the way around, so we really want to have center lines in the other quadrant as well. So we would see something like this, and I'd get my center line. So it does something like that. So in the top view, you're going to see this slot with center line running down the middle of the slot, and then a center line at the center of the hole on each end of the slot. Those numbers are dimensioned. Now, when you're drawing this in section, these center lines that were here at the end of the slot will project upwards, and you'll see them in the section. Well, what about this horizontal center line that goes through the middle of the slot? Will we see that in the section? No. We'll only see any of these center lines that can be projected upwards. And if possible, try and make it so that the dashes for the center lines line up. Not always possible, but you do what you can. Now, when we're cutting the section through here, there is a hole in the background, right? So we will need to see the hidden line for this hole here shown in the section. Yes. Well, then what about our major hole? Then you'd end up skipping the major hole. That would be the problem. So yeah, no, that's right. So I mean, you're kind of damned if you do, damned if you don't here. So the question was, because this is just for the YouTube stream, that why can't I take my section line, jog it here, come up and pick up this small hole? Because then you'd be forgetting the larger hole. So in this case, we keep the section line following sort of the most significant bits of the part of the geometry, and keep going and working our way across. So this is the tricky one. So these center lines here coming up from the ends of the slot, center of holes, those are important. And then a hidden line for this one recessed hole here. And so again, I goofed up on this line, shouldn't be here, this horizontal little piece. And so, in terms of this should just all be one continuous bit of sectioned area there. Object line going across. I'll put my red lines on there. So that's, and I'll continue with the sectioning here. Now, in mechanical drawing, we don't show an extra heavy line for the sectioned area versus lines that are just background. But as you're planning it out here, and this material hatch line would come down here like that. That is what your section should appear like. So that just kind of walks you through this one. And so we're cutting right through the middle of this thing. So this material steps up to that raised part in the middle. Would we see a hidden line in the background? We actually would. So going across here, this wouldn't be a solid line. It would be a hidden line from here to here. So you'd see a dashed line going across on each side. Not super critical if it's not there. The top view certainly, you know, illustrates what's going on. Okay, I just got to go back and look at the assignment here and look at the next one. So 183. Okay, so the piece de resistance. This is a situation where you're going to be drawing a top view and the section. So the main thing that you want to make sure that you get correct on this assignment so if I lay this out in plan, I'll just draw it very simplistically. Don't forget you've got your keyframe here. So, or your key for the shaft. So I will draw that in here and make sure that that key is at the top of the view. Oh, it comes in closer. Okay, this is going to be a mess. Like, I mean, really a mess. Like, I should go back to kindergarten. Okay, mostly what we're just talking about here is the sectioning strategy. So when we're talking about the section, we've got our keyway pointing up. So that's important. And so our section is going to come right down this axis. So I'm going to draw where we're actually going to draw the section line using the red ink. And it doesn't actually matter which direction you choose to cut the section in, but you just need to be consistent when you show the graphic for the section when you go down one of the other arms. Now, it doesn't even matter which arm you choose next. So if we decide that we want to look to the left with the section, well, you can come down the left arm or the right arm. All that matters is that whichever direction you choose to go, that you make your section arrow point in the same direction. So you want to go down the right one, fine. But if you want to go down the left one, that's fine too. But you just make sure that the arrow that you show at the end points in the same direction, whichever way you go. Now, when you actually get to drawing this thing and showing where the section is, so I'm drawing that in black now, don't draw that section line going down the object itself. We don't want to hide anything. So just draw that section line outside, and that's good enough. So just make sure that your direction of your view is consistent. So with this section, what's going to happen when we look at it is we're going to see you're going to be cutting through the slot. So it's going to be, so when we draw the section, make sure that your hub points towards the top view. So if I was looking in this direction, I'm looking at my section. Actually, no, this is actually going to be a really good learning point here. There's actually something wrong with this whole layout. Does anyone feel that disturbance in the force? What has the instructor done wrong? There is a mistake here. Now, is it in the section or is it in the top view? There is a mistake. It's a pretty straightforward one. It's actually No, it's not. No, it's not in the webbing actually. It's in. Well, this would give it away. Um, no, it's more about the directionality of how I'm showing the section on the top view. They're pointing the wrong way. Yes, exactly. So if I've got my section view here, the section is actually looking in the opposite direction because here, and so some people would say, well, this doesn't make any sense because if you're really drawing this the way that I'm shown, I should have mirrored this so that the hub is pointing in the opposite direction. So really, this is just needs to be mirrored and drawn in the opposite direction, like this. But the problem with this is that then we've got the other problem with the convention is that the hub in the section is pointing away from the top view. Well, okay, so what should I have done here? I could have taken this view, exactly. The best way to do this would have been to have this view, so in reality, this is correct. This would be wrong. Then we would, exactly, switch the arrows around, draw that section arrow looking the other way, and I could either just switch the arrow here and make it look the other way. I could do it there, or I could, do it over here. The other side of the arrow could be, so any one of these could draw the section. And now my hub in my section would be pointing towards my other view, and that would actually be preferred. Now, the other correct way to set up your page here then would be to have the top view of this thing. It's even nice is to have the previous sketch that I had under there before, so I can sort of work out some corrections as I go. You guys can see just why trace paper is so awesome, because you can see the previous stuff that you did before and the mistakes that you made, and then come back and sort it out. Just make those corrections as you're drawing through the trace paper. I love trace paper. I wish life was trace paper. Okay, so now my section is on the right hand side. This is good. The hub is pointing towards my top view, so that is preferred. So now what I do with my section is I'd make sure that my section points in a logical direction that is looking in the same direction as the section itself. So this is also correct. So you could do it either way, but you just have to put the top view, in the right place. And it's just all about which direction you draw the center line in. So if you do your top view and your section view and you're like, oh, I actually, is that going to affect me? Don't worry about it. Just make sure you got your section lines um, pointing in the right direction, and then away you go. So now the other thing to keep in mind is you want to make sure that your keyway is at the top. So always your keyway, let's show the slot for it in the section. Of course, the keyway itself is not sectioned. So the sectioning of the material comes right up to the edge of the keyway and begins. So what's going to end up happening is that the hatching on the side without the keyway is going to be a bit wider than the hatching on the other side with the keyway. So that's just going to affect how the sectioning goes. Okay, so that's it. That's kind of how this whole assignment is going to break down. So yeah. Well, yes, you would. No, hold on. No, you wouldn't. And the reason is that you're cutting right through the center of it. If there was some holes around here, there would be some hidden lines involved. But here, you're cutting right through the middle of it. So the only thing that you are going to see, because these things are on a curve, there's a bolt circle here, right? So this thing, as you go around, now, does it say bolt circle here anywhere? Yeah, right there, 133 bolt circle. So there is going to be that provided. Now the bolt circle actually doesn't even need to be continuous, so you can draw a piece of it. So in the white space around the edges here, just make sure it's the same radius, obviously. So there's my bolt circle there, and then another piece of it up here. Right, so my bolt circle is indicated all the way around. Do a little center line that comes out and get that little nice plus happening where the two intersect. And then in the center here, now they've shown at 90 degrees the different center lines. I think I would probably just stick to 120 degrees just because it's confusing. I sometimes I see mechanical drawings where the hub, even on a 3-spoked item, has horizontal, like at 90 degrees, some center lines, and I'm like, that's confusing because if there's no holes or anything to warrant having that, that center line at 90 degrees, this is not organized by 90 degrees. It's organized by 120. So that's just confusing. Now, yes, the webs here would be shown in plan, but not in section. Now, the next question is, we have around 100. Oh, no, so what? No, it's 25 here. See, there's 25 at the bottom times whatever tall. So, yeah. Now, I'm looking at this here, and because this is a fillet, really in mechanical drawings, they would show it like you're seeing here because it's rounded at the bottom. I think most mechanical drafters, even though this is rounded at the bottom and normally you wouldn't show that rounding, they would just cap them off anyway, even though there is a round. And so technically speaking, if I've got a fillet at the bottom of this thing, I'm not going to see this line because of that fillet, right? Because it kind of makes that line disappear. The reason we're seeing the lines on the ends of our webs is just because that's their ultimate width. So fine. In reality, of course, what this thing looks like, it's curved, and as it goes downwards, right, it's kind of got this rounded both across the top of it as it hits the flange and goes down, and then when you get to the bottom, it also is rounding out in all directions like it's filleting. So it makes it super smooth. So those smooth lines kind of, you wouldn't normally see it, but it would be just too weird not to have the line at the bottom. So it's, still going to be shown. So there's another one of these tolerances here. So you just put that in as text. What do you draw it at? Draw it at 35, because you're just not going to be able to get that 34.7 to work. Now, this has 2 parts to this. And this is something that we will catch in section. I just realized here my section here we need to discuss this. So we've got the tolerance for the drive shaft that goes into this thing. That thing is 35. Now at the bottom here, through this plate, and this is actually a really good point. I got to redraw this because I made an oops-a-daisy. Okay, so this goes to 2 parts. We've got the 30 diameter core through the bottom plate that these 3 prongs, these 3 spokes are on. And then we've got the hole through the flange. So this flange would be maybe welded on. This thing might be all cast and then drilled. So this thing might be a cast part and then it's drilled for everything it's got to do. So it would start life out. This slot wouldn't be cut. The webs would be here. The keyway wouldn't, and the hole wouldn't, and the core in the bottom wouldn't either. So let's look at section and just see what this thing would really look like. So 35 diameter hole with a core at 30. So this means that as we come down to the bottom of this thing, it actually steps over a little bit. So there's the keyway. So at the bottom here, this is 30 in diameter, and at the top, it's 35 in diameter. So that is what we're going to see. Let me get this other piece out of the way. So there's the 30 core at the bottom, 35 at the top. Here's our webs coming down on either side, and then we will section it like this. So keyway doesn't get sectioned, and then it gets a little bit thicker as we get down to the core, like so. So that's what that is talking about here with the core. Okay, then the center line down the middle here. Center line's here for the center of the bolt hole, or where the drill hole was made to make that slot. So you can have those 3 center lines like you see there. Yeah, and the section is going to go through the keyway. So when you're drawing the section for the keyway, of course you want to make sure that the direction that you're drawing the section here, the keyway should be on the top of the section, and it is here. And then I didn't even draw the keyway on the other example. So that's just another thing that you need to keep track of when you're doing your section. So here's the way the section really should look, with the smaller hole in the bottom of it and a keyway visible with a larger hole at the top of the hub. Okay, I'm going to stop the stream and then we'll take some